Okay, so I think we should start. So welcome everyone to the Women in Engineering Extraordinary Women, Extraordinary Science Seminar Series. This series started under the umbrella of the 25th anniversary celebrations. And I'm really delighted to have our first speaker after the summer vacation today, Professor Holly Handley. And as you can see, she will be talking about the human system engineering community initiatives from human views to human readiness level. Holly, she will introduce herself, but I am particularly enthusiastic about the presentation today because she will be discussing these very timely insertions and the inclusion of the human aspect within engineering and system engineering. So I would like to thank all of you for being here. Of course, our speaker today, and a special thanks to Ramalata Marimutu, who has been taking care of the production of this beautiful and organizing with her team, of course, of all this beautiful presentation and introduction of the speakers. Joregna Brown, who is an invaluable member of the team in organizing all the publicity as well as the website, and of course my co-organizer Bozena Passing Duncan. And I will not really take more of the time of this extraordinary speech, and so Holly, the floor is yours. So everyone, please put your questions in the chat and for the end, and so Holly, to you now, and we will be discussing again with all the public at the end for questions and answers.
Super. Thank you very much. So my name is Holly Handley, and I'm a professor at Old Dominion University in Norfolk, Virginia. And I'm very excited to be part of our Extraordinary Women, Extraordinary Science series here today. So as Cynthia said, the title of my talk is Human System Engineering Community Initiatives from Human Readiness Levels, or from Human Views to Human Readiness Levels. But before I get into the main content of my talk, I thought you might be a little bit interested in my career as an engineer. So I've tried to sit in as many of these talks as I've been able to. And I've actually found that the introduction section, where we learn about the different people and the different challenges that they faced and how they the different paths that they've taken to where they are today, that's almost as interesting to me as the technical content of their talk as well. So I thought I would just take a little bit here at the introduction and give you a little bit of background about my career path. So I got my Bachelor of Science in Electrical Engineering at Clarkson College, now Clarkson University, a small engineering school in upstate New York near the Canadian border. And when I graduated, I took a job with Raytheon down in Newport, Rhode Island. And at that time, they had just won a new submarine contract. So they hired like 200 new engineers from across the Northeast. So it was like being at college, only we got paid. There were softball leagues and events, and it was a wonderful experience to be introduced into an engineering environment. And as part of that effort with all these new engineers, they offered a program where they would send you back to get your master's degree. So I took advantage of that, and I went out to the University of California at Berkeley in California and got my master's degree in digital design. Then I came back to Raytheon and worked in both Rhode Island and California as a CMOS application engineer. Then I actually took an assignment as a field application engineer in Vicenza, Italy. Then I decided I need to improve my kind of management side skills, so I got an MBA at the University of Hawaii. And then I went back to engineering and got a PhD at George Mason University in Fairfax, Virginia. My thesis advisor at George Mason, while it was he was part of the electrical engineering department, a lot of his work was crossing over into systems engineering. So I got exposed at that point to a lot of the processes and methods for system engineering. And so when I came out of my PhD program, I actually took a job as a systems engineer in a small business out in San Diego, California. And in this small business, I was really the only system engineer, but I worked with a lot of human factors integration engineers and human system integration practitioners. So all of a sudden, my world expanded a little bit where I learned more about this kind of human component in systems engineering. Then I continued with them in both Biloxi, Mississippi and Washington, D.C. Then I ended up here in Norfolk, Virginia, where I took a tenure track position, so as an assistant associate, and I just recently made a full professor here at ODU. And so I thought it would be interesting. At the top of the screen, there's a picture of me as a young, enthusiastic engineer. And at the bottom of the screen, it's a little bit more realistic how I look today with gray hair, which kind of matches that full professor designation. So you might be interested why I moved so many times in my career. So actually, when I went out to the University of California, I got engaged and then got married to a U.S. Navy officer. And so many of you may be familiar with the military, you move a lot. So my challenge as I tried to keep my career focused on engineering was to be able to have a dual career path with my husband. So you can see those moves back and forth across the country are all two areas that have a naval presence. So where my husband was being stationed. And so I really feel that I was an early leader in trying to keep a dual career going as a military spouse. So for example, when I was in Vicenza, Italy, this was before email and internet. So we had a fax machine. So I actually worked for the California office. So the fax machine would go off all night. And then in the morning, I would pick all the papers off the floor and plan my work for the day. And so I feel that I've had a successful career. My husband retired as a two-star admiral back in 2014. And I just have a little bit of unsolicited advice for those of you who are trying to make dual careers work. I found that networking and engagement is really the key. You have to be willing to talk to people, to find out where opportunities are, to see, what are some things you might be able to do, and to make suggestions to your company. I actually suggested to that small business that being in Biloxi, Mississippi would be a good thing. And so I kind of made the case for them to continue to employ me while I moved there. The other thing is some of this is just being in the right place at the right time. For example, my work that I'm going to talk about today, the human system engineering, I just happened to be in a meeting where people were beginning to talk about this. And I kind of volunteered to get involved in the effort. And it's really turned into a broad and fruitful research area for me. And then lastly, I really feel like you have to have some individual vision about what you want to do and what you're willing to do to make it work. And I kind of align it to if you're in a crowded parking lot and you're looking for a parking space, the last thing you want to do is follow somebody because they're going to take that spot. So you have to kind of be willing to kind of chart your own path a little bit and take the opportunities that appeal to you. So that's all I really wanted to say about my background, and I'm glad at the end of the talk, if there's some time left to answer any questions about my particular road that I took to get to where I am today. But now I want to get back to the topic on hand. So my topic for today is human system engineering, and I'm here representing the IEEE Systems Council as one of the IEEE's councils, and I've been involved in this community as leading their Women in System Engineering program. So many of you are familiar with the concept of systems engineering, which is basically the integration of all systems to ensure system success and stakeholder satisfaction. But more and more, we're recognizing the need that we need what I call human plus systems engineers. So the integration of the needs of the humans into all systems to ensure optimal performance and safety. So that quote at the bottom of the screen is from kind of our governing body, if you will, the International Council of Systems Engineers. They have a quote that says, while many systems engineers understand that the human operator and maintainer are part of the system, they often lack the expertise needed to fully specify and incorporate human capabilities into the system design. And so that's the gap that we're trying to fill as human systems engineers. And so you can see the little figure at the bottom of the slide here. You know, many of us, especially in our kind of electrical engineering world, are really focused on integrating our hardware and software and making sure that they communicate and work well together. So we also just have to add a little bit breadth here and make sure we're also considering the operators or the users, as well as the maintainers, people who will have to access the system from a different perspective and for different needs. The last thing I want to point out is those two book covers that are at the top of the screen. So I actually teach a course in human systems engineering here at ODU, and those are the books I use in my class. And they're not textbooks, but rather they're true stories of what I call human and technology gone wrong. And they're super interesting about, sometimes it's on the human side, sometimes it's on the technology side, but the fact that they're all true stories makes it even more interesting. So if you are interested in a little more kind of background on this area, those would be two good places to start. So this human systems engineering is a pretty vibrant community. It's made up of really systems engineer, human factors engineers, human system integration practitioners, and other people we kind of recruit along the way into our community of interest. And so basically we focus on identifying and improving methods to integrate human concerns into the conceptualization and design of systems. And our focus is on kind of the early intervention, early understanding of human roles and responsibilities, along with limitations and constraints that may impact system design. You know, traditionally in large system design, kind of that human interface, human integration part was often left later in the system development process. And at that time, it was often too costly to make the changes that would be necessary to really improve the system. And so our human system engineering communities initiatives that I'm going to talk about today really encourage that from the start of the system design to be cognizant of who your human operators are. And so today I'm going to talk about two different things. First, I'm going to talk about the human views, which was a little bit of an earlier effort. It kind of started a little bit before 2010. And then I'm also going to talk about the human readiness levels, which started about 2015, but really has just matured within the last year. And so you can see on the side of the slide there, we have our system engineering V, where we go down, the left side of the V is kind of our design and development, and then go back up. On the right side is our test and deployment. And you can see the human views really are a tool that we used in the conceptual architecture and design phase, while the human readiness levels track the system throughout its full course of development. So first, a few words about the human views. And the human views are really used in that system architecting stage. So in system architecting, what you're trying to do is move from your concept to some alternatives for design. So at this stage, you're starting to make some models. You might include some parameters that you want to test. You might have some alternatives. So we're not quite to the design stage, but we're working out the details. That's how I like to think about system architectures. And there, especially when we talk about complex systems, they really provide a mechanism for managing this complexity because they kind of tease our system out into different perspectives, which allow us to focus kind of on individual aspects of the system. So you can see that kind of triangle there on the right side of the slide, kind of the three main perspectives that we tease the system architecture apart into are the operational view, which is kind of the functionality. What are the functions that we want this system to have? Then at the bottom, there's a systems view. This is more about the capabilities and kind of thinking about kind of what is the hardware we envision using, and more about the physical structure that we envision for the system. And then the technical view over there on the side is more about the standards and conventions that we need to adhere to, especially with a complex or system of system where we need multiple pieces kind of talking together. So we do have architecture frameworks in place to help with this. And the one that we use here in the US most often is the Department of Defense Architecture Framework. But I will offer to those of you in other places that almost every country has something similar to this to use in their architecting process. So for example, Canada has DINDAF and the UK has MODAF. So this is not restricted to a US development, but this is an example that we've used. And the main thing that will pop out at you when you start to use one of these frameworks for an architecture development is there's no perspective on the human. There's nowhere to start to capture aspects of the human roles that you envision as you're working through your design. Oops. Excuse me, something is happening here. Great, let's try. There we go. So, so this figure on the side here kind of explains a little bit about more of the human viewpoint goal. And this is most often used when we have kind of a complex system of systems. But you can see in that example, we have kind of a sensor up in the sky. We might have some airframes that it's giving information to. We may have some ground units that are responding to some information, and we may have some naval vessels out to sea. And generally, when you work through an effort with systems interacting like this, you get really focused on the technical aspects. What are the interfaces? Can they exchange data? What is the frequency that they're using? And so forth and so on. But often the fact that there's human operators in each one of these systems is completely disregarded. And that's kind of surprising since these human operators make decisions that are going to impact the success of this system of systems operation and the goals that they're trying to achieve. And so you can see on the right side of the screen, here we have that triangle again of systems, operation, and technical, and some of the models that we use on those. But what we want to drop is we want to drop this human perspective right on top there. And so the objective of the human viewpoint is to provide a perspective on the human roles, activities, and information flows that are being driven by this human side of the system within our complex system. So surprisingly or not, it was actually NATO that instigated the development of the human viewpoint. So back in the around 2007 or so, NATO was embracing a philosophy of network-centric systems. So information technology was now prevalent. Our systems were becoming much more interconnected and data-driven. And so NATO had a philosophy of people first, process second, and technology third. But when they went to try and apply this philosophy to their system development, there was no place to put the people, right? So they reached out to, this had already been noted as a lacking in our architecture framework. So they began to reach out to people who had done some work in this, maybe published a few papers, and they brought a group of us together. It was actually in Toronto, where we had a 3-day workshop where we really talked about, we're all involved in the system architecting process. We've all realized that we need to add this feature to our architecture so that we can really make them robust enough to handle our human component. And so at the end of that, we came out with a template for a human viewpoint. And you can see there on the right hand of the side, these are some of the different views or models, or you can consider them as like, data buckets. What are the things we need to understand and flush out? So first of all, the kind of the concept of the humans in the system, what are their roles and what tasks are they trying to perform? What are the constraints that are driving their work activities? And what is that human network? What is that interconnection between the human operators? What is the training that they're going to need driven by these other requirements? And how are we going to evaluate their performance? And do we have enough information here to roll that into a simulation model where we can actually show the impact of different human capabilities and limitations on overall system performance? And the flip side of that is, can we show how changes to certain aspects of the system impact operator performance? So the human viewpoint was designed because it was this international panel. So it was independent of any specific architecture framework. So for example, it's not driven by that Department of Defense architecture framework that I mentioned. It can interrelate with any architecture framework that's being used. It's also adaptable to different implementation processes. So if you're going through different systems engineering methods, this should be able to align with that. And the last thing was, we wanted to use data from the overall system development effort to build the models. And what this means is there was already an increase in the number of perspectives from the 3 that I showed you to 8 that were released in a second version of the architecture frameworks. So system engineers were already starting to push back on, there was a lot to do. And so we were able to show how some of these human view models, if you will, could draw data that was already being developed or identified in the regular system development, and then just kind of rolled into and perhaps further decomposed for used in this view. But overall, the goal was to ensure that the human component had visibility as part of the system architecture. So what's the utility of the human viewpoint? The human viewpoint got matured by like 2015. It had we had submitted our NADA report. There was a human view handbook put out and many examples and articles of how to use it. And it took a little bit to get traction in the systems and engineering community. And so some of the kind of selling points for the human view are, it really facilitates communication with other disciplines during system development. Because you have a viewpoint at the table, if you will, during the early definition of different system entities, it really facilitates that conversation with systems engineers in other domains who may not have been cognizant of thinking about this at this stage. It also organizes information for a comprehensive representation of human capabilities. So I mentioned before, a lot of this information was already being discussed or put out there. Now we have a place to record that. And so if you kind of flush out all of the human view, you really have a complete representation as you work forward through your system engineering design as a reference to design decisions as you move forward. And finally, it's also a set of models. If you develop them, you can provide a fully integrated set of models that you can then use for simulation. So it can inform and influence the design and development of your system. If many of you are familiar with the human system integration community, they work with the system engineers as a system progresses to make sure it's addressing certain domains. And the human view provides some early linkages to those domains. But basically, you can see the figure there on the upper right-hand side. The colored blocks are the human view, and they're nestled right in there. The other blocks are different architecture products. So you can see as you kind of make changes to your definition of your human, that impacts your system design and vice versa. So it's an integrated viewpoint with the rest of the system data. And again, it was not designed just for the US, for example. Here we have the Human View Handbook for MODAF, which is the UK version. So by 2015, it was matured. There had been some gradual acceptance of the human view in the systems community. And what really kind of pushed it forward was when the systems community adopted more model-based system engineering approaches, because then the human view is being created in the same types of SysML models that the rest of the system was. So it was really easy to integrate and decompose system data into the human viewpoint. So it's on its way, I would like to say, to being a more to being an accepted viewpoint with the rest of the architecture framework. So that's kind of the first part of the talk. Now I kind of want to transition to this idea of human readiness levels. So right about the time that the human views were maturing, this second idea was pushed forward about human readiness levels. And a colleague of mine, Micah Ensley, who was the chief scientist of the Air Force at the time, in 2015 gave a talk about this idea of human readiness levels that had been out there before, but she's the first one who kind of promoted it to this human systems engineering community. And so the human readiness level is described as a measure of the readiness of the technology for use by human operators and maintainers. So while the human views provide a tool to integrate the human into the system design, the human readiness level is like a metric that follows your system development to communicate how well or how much of that integration that you've done. So as you can see in the second bullet there, a communication tool to describe the degree that human aspects have been considered in the conceptualization, design, and deployment of systems. And so the human readiness level is a 9-level scale. So it's just an index number. And originally, the criteria for those levels was tied to that human view data. Since then, the scale has been updated and refined, but at the time, this was a nice transition from people who were just getting their hands on the human views. Now we were kind of segueing them into the human readiness levels. But again, the idea of a human readiness level is that it summarizes the outcomes of human system integration activities into a standard metric. So the human readiness levels were purposely designed to mimic the technology readiness levels that many of you may be familiar with. So the TRLs, they've been around for probably 20, 25 years in the US, in the Department of Defense, in NASA, the Department of Energy, and they're most often represented like this thermometer, right? You start low, you're at TRL 1, when for a particular technology, you're just doing some basic research, you're understanding what it is. And then as you mature your technology, your TRLs increase. You've done some research to prove feasibility, you've done a technology demonstration, and then finally it's integrated into a system that's been fielded. So the idea between the HRLs was that they would mimic that. But at HRL 1, you're doing some basic research and use definitions. By mid-range, you're doing some initial modeling, analysis, and testing. As you get up higher, your design is matured in a representative environment. So the HRLs are designed to complement these TRLs during technology development, but focus on the readiness of a technology for the human element within a system. So Micah, as I mentioned, Micah proposed these in 2015, and it took a while for those to kind of make their way through the community. But in 2019, a HRL working group was formed to kind of take a look at that scale, see how we could mature it. And our goal at that time was actually to turn it into a standard that would be available to human systems engineers, human factors engineers, and human system integration practitioners. So we formed this industry-wide working group. It had 35 members from across the Department of Defense, Department of Energy, academia, and industry. It was a wide variety of folks. And it was also supported by the Human Factors and Ergonomics Society's Government Relations Committee. they had identified in their work that this focus within the Department of Defense on the human element had been decreasing over time. And they felt that something like this human readiness levels would really put the focus back on the human operators and maintainers. So they provided some support to us to work through the maturing process. So we had our first workshop out at Sandia National Labs in New Mexico in the fall of 2019. And what we did here is the set of 9 HRL definitions, those were pretty well set. But what we worked on is what were the criteria or conditions that had to occur at each level to say that you've addressed this particular level and that you could exit that level and move to the next one. And we frame these as questions. So for example, has an HSI evaluation been done on the system? Something like that. And so at the end of that workshop, we had 80 questions spanning the 9 levels from initial concept development all the way to fielding. And along with that, we had exit criteria and what was the supporting evidence? Were there particular tests or evaluations that should be done at each level? So coming out of that workshop, we had a really good version of the tool, if you will. Then the second workshop was to be held at my university, Old Dominion University, in the spring 2020. We all know how that went. So it turned into a series of 4 virtual meetings. And what we were doing here, we wanted to kind of put the scale through its paces. So we identified a varied set of examples. Most participants brought some with them. And what we did is we broke into groups and we worked through the scale based on our knowledge of the system. It was kind of a forensic analysis, if you will. And what we were trying to show was that if the HRL had been used during the system development, some known flaw may have been caught earlier. And the other thing we wanted to check was some kind of inter-rater reliability. So if we have multiple people working with the scale on a particular case study, are they all kind of converging to the same level, or are they all over the place? Because to be a useful tool, it should guide you to identify that correct level. So when we came out of this second workshop, we had a few more tweaks to make, but then we handed it over to a writing committee for our ANSI standard. And that happened in September of 2020, and by September of 2021, so let me take this back. So the standard was written by a writing committee. It went out for peer review. They came back with 285 comments, which were ameliorated. It went back out again for peer review. Then it was submitted to ANSI. So it was a full year approval process. And you can see here is the standard as it was approved. The ANSI HFES 400 2021 standard, human readiness level scale in the system development process. And it's available for free from the HFES website. So what does that number indicate? So let's say your system or your system designer, your HSI practitioner comes back to the program manager and he says, okay, you're in an HRL 4. So what does that mean? Well, that's telling them the degree to which human-focused requirements are defined and addressed during system development. So you can see I have this is a handout we have on the side of the slide here. And this is a helmet mounted display. So you can see down here at levels 1 and 2. So this would be like in the concept development, in the laboratory. What do we envision the system to look like? Where do we envision the touch points with the human might be, for example? Then we start to move up into CAD models, and then maybe a laboratory mock-up where we can do some usability assessment, we can do some task analysis, some cognitive load analysis. Then as we move further, we start to perhaps work with a more fully defined system in a laboratory or a mock-up of the actual environment. Then as we get to the higher levels where we're starting to get ready to deploy it, here we have a user in the actual kind of lighting conditions out in the field, and then the fully deployed system. So as you go through your scale from 1 to 9, you're getting a more realistic and refined system, and you've been evaluating at each step of the way that it's ready for human use, if you will. And you can see this colored arrow here is risk. So as you work your way through the scale, it's easier to make changes here and take care of problems as they occur. And if you work your way through the scale, there should be very little risk here as you go for full deployment. So this HRL captures things such as whether research on human needs, performance limits, and capabilities with the technology has been carried out and incorporated into the system requirements, whether system integration requirements have been taken into consideration in the system design, and whether human capabilities have been demonstrated under test conditions with increasing approximation to operational use. So let's say you've got the standards, you're going to evaluate the human readiness levels on your system. Of course, it takes resources to do that. So what are some of the benefits of that? Well, first of all, it provides a common language and a consistent framework for addressing human readiness across diverse programs. So this scale can be applied to whatever type of system or whatever type of program that you have. So it's consistent and it's common language, if you will. The other thing is it really shifts the focus from lagging indicators of human readiness, meaning lagging means you have an error in the fielded system and you got to figure out what to do, to leading indicators, meaning early on in the design, you can catch things based on some of your evidence-based measures of usability readiness. And we do have targeted HRL values across our system acquisition process. So at certain milestones, your system should be at a certain human readiness level, and that's aligned with the TRL for that level. So the HRLs allow you to identify actionable items. They can impact the allocation of resources. So for example, if you're falling behind, your program manager may channel some funds there. And of course, they influence design decisions as you go forward. All right, so now kind of circling back and wrapping up a little bit. So human system engineering is really engineering for the total system. So we have our human views as a tool to use during our early system development. They capture human data for engineering design and analysis. And you can see we have a set of views that were designed that include everything from constraints, tasks, roles, that human network, training, and metrics. And then we have our human readiness levels, which assess the degree to which human requirements have been addressed throughout the whole system design process. And you can see they're pretty consistent as you go through increasing levels of fidelity as the HRLs increase. They look at things such as usage scenarios, human performance metrics, human machine allocations, our safety, the environment, relevant HSI domains, strategies for human usability, users, procedures, and of course, an issue tracking system. So we have both of these tools available to us in the human system engineering community to work with our human system engineers as a design goes through that system engineering V. So overall, practice human system engineering can help reduce system risk. It communicates information about the needs and limitations of the human component, and its goal is to ensure that systems will not require those expensive late-stage train-arounds to address issues of unaffected usability. So a lot of this work, or a lot of my research, has been funded by the Department of the Army. And I just want to be clear that even though a lot of my examples have been kind of military focused, these are tools for across industry. In fact, I just had a talk with the FAA, the Federal Aviation Industry, I'm not sure what the last A stands for, administration, to talk about how we can use these tools with their next gen flight systems. But I want to call out this figure here on the right side of the screen, So in my funding in the Army, I worked with Dr. Beverly Knapp, who was the acting director of Army HSI at the time. And her mindset was whenever we talked about different systems, different tools, this was her goal. She wanted to know that this soldier, and you can substitute this person, this worker, with their set of skills, abilities, and experience as part of this crew or team or organization with this training that we will provide or they've already had, can they perform their assigned tasks under their work conditions using this new tool? So that's kind of the encompassing goal for a lot of our human system engineering efforts. And I also want to call out that quote on the bottom of the screen. Sometimes we get so caught up in the cool technology that the technology or the system takes precedence. But in reality, the aim is not to train an operator to work a machine that is designed to achieve some goal, but rather the aim is to design the machine to support the operator who is responsible for achieving the goal. And I think sometimes in today's world, we get those two things flipped. Okay, so in conclusion, if you will, so comprehensive integration of the human component into the systems engineering effort is critical to the design, development, and operation of successful systems. And the two tools that I talked about today, both our human views and our human readiness levels, enable successful HSE efforts. And supporting human plus systems engineering can reduce total ownership cost and improve the overall system performance. And then one more quote for you there in the blue box. I think we all know that when you find a problem in system development, everyone gets worked up because it's 10 times more costly to fix it during development as opposed to having corrected it in design. However, if it makes it through development out to a fielded system, it's 100 times more costly to fix it after the product is released. So both the human ready views and the human readiness levels can help enable successful HSE efforts and catch those human issues early in the design effort. Okay, so that's my talk for today. Again, I'm Holly Handley. I work in the Systems Engineering Department at Old Dominion University in Norfolk, Virginia, and I'm happy to take your questions or comments at this time.
Thank you. Thank you very much, Holly. This was an absolutely amazing presentation. I can see that there are already questions. But before doing that, I would like to ask all the attendees to unmute to give you a very deserved applause.
Thank you very much.
Okay, and so I can go through some of the questions. We're starting from the first, from Walt Downing. Congratulations on your elevation to full professor. I enjoyed your talk very much. You are an outstanding representative of IEEE System Council. Will you be organizing sessions on HRL at future conferences to share experiences and promote the use of these tools in the future? If so, when and where?
Thank you for that question. So actually at the upcoming Human Factors Ergonomics Society annual meeting, it's in Atlanta in October. We do have, I should also give a shout out to my colleagues on this effort, which is Micah Ensley and Judy C. from Sandia National Labs. The three of us are running a workshop on the Monday of that week on human readiness levels. But that's kind of on the human factors side of things. And I'm more than willing, Walt, to work with you perhaps at one of our future SysCons to bring this information and either in a session or a workshop. So we can talk offline about that.
So the next question is from Bethany Darkey. So working in defense and aerospace, these examples were great. Two questions. When designing products and systems for the DoD, how do you best get the test data required for understanding the operations and restraint? And so, and further, how do you test your system design, calculate constraints at these stages while maintaining safety, morality, risk of testing of humans?
Yes. So I believe the first question was about collecting data. So on the larger projects that I've been involved with the Army, they do field testing at certain stages of mock-ups and then in the field. And they give them questionnaires, they collect real-time data. So when I've worked on contracts with one of the military organizations, collecting data has not been a problem. For the second one, so we do use some modeling and simulation tools, and I may not understand your question totally correctly, but on the early stages, one of the tools we used is called Imprint, where we can start to put in some work processes that have workload things. We can put in different things about the environment. We can put in different aspects of the system, and we can start to do some early simulations about human performance, meaning timeliness, accuracy, and errors using the simulations. I should also add that a lot of these larger projects are improvements over previous projects, or we have a lot of data from kind of previous iterations where very rarely on many of these things have I had to start from scratch. So on every development, we still start for the HRLs at HRL 1 and do the evaluation. But as we're going through, for example, the human views, there is some data and some definitions available already from previous iterations. And I hate to use this as a caveat, but everything is very system dependent. So it really depends what is the type of system we're working on, and what are the areas for every system. For example, not every HSI domain is as important as the other. So especially at the system architecting phase, a lot of times we're just zeroing in on specific stakeholder areas of concern and kind of focus in on where we think the problems are going to be. I hope that answered your question.
Thank you. And there are more people thanking you, Ifra Adiz, Irene Magara, and of course, Bethany Key, she's thanking you. And there is another post from Fogor Tanshi, very enlightening. Human factor is often overlooked, and there has been more hype about fully autonomous systems, excluding humans. Please, can you run through a user scenario using this human readiness level? Thank you.
I'll just make a couple comments on that. So, manned unmanned teaming has been a new area of research where, as in some of our teams, we have humans operating systems, but they're partnering with autonomous systems. And so not so much the human readiness levels, but we've been looking at the human views because this really crosses a gray area when you talk about architecture frameworks. So architecture frameworks try and put humans in a pot, technology in a pot, functions in a pot, and our constraints. So the thing when we start to talk about autonomous systems, they are a technology or they are a system, so they belong on the hardware side, but they're also acting in many cases as team members, right? They're becoming part of that human communication network. They're taking on certain roles in the team. So in other cases, they're kind of on the human view side. So this is actually a new area of exploration. So how do we best capture the idea of autonomous systems when we're trying to break a system into these different perspectives? Because as I said, sometimes these autonomous systems are almost like a team member, but other times they're just a technology. So I actually have a paper in this upcoming SysCon that starts to talk about how the human view can help to address these kinds of issues. So that's a few comments on that. I'm not sure I addressed that question directly.
Thank you, Holly. Are there other questions or comments?
And I
from the
would just
audience?
also like to offer that my email is there on the screen. You know, I have a lot of materials on both the human view and the human readiness levels. So if anyone wants to reach out to me, I'm glad to share some information that I have, or if anyone wants to have an offline discussion, I'm happy to engage in that as well.
Thank you. Thank you very much. And please, everyone, know that, of course, all this information will be on the website for future interaction and if you need more information. So, Holly, this was really so incredible. And there are so many questions that are popping to mind. And one that I have is maybe referring to the limits of all that. But of course, we know that some of the goods of technology, and sometimes, as from the last questions, having technology at the center means that you can take advantage of characteristics of the technologies that are maybe lacking in human, like speed, for example. So the responses might not really be from human side, the height of what the technologies can offer. And so how would you evaluate the limitations of centering the responses and centering the systems to humans? Because of course you need to keep the technology and the human side and the readiness levels, as you mentioned, going on in parallel. But sometimes probably these type of characteristics like timing and responses might really be a limitation.
Yes, I agree. And I think, you know, one of the keys to take away from both of these tools is that they're customizable for the system under evaluation. So as I presented, they kind of have this broad scope of values and the things they're evaluating. But when you apply them to a specific, and even within a certain organization, a specific type of system development, I mean, the first thing you really do as part of your concept is identify what are the critical aspects that are really important to this system. And then we can tune both the HRLs to kind of make sure that those critical aspects are the ones that are actually being monitored through the progression of the system. And I think, you know, that kind of reflects back on the previous question as the role of humans and technology is changing, right? So when this HRL effort was first started, and even before the human view, I mean, the human operator was the decision node in this system of systems. You know, often now that's shared or offset to a autonomous system or some kind of AI or neural network. And so I really think we're entering into a new realm here of defining this kind of quasi-human role of technology. And other than I agree and identifying this as an area, I really think this is where we need to spend some time thinking about this to make sure we get it right.
Yes, I agree with you completely. But it is so fascinating, and thank you so much, really, for bringing that out here, and so giving all of us the opportunity to listen to that. To me, actually, it is really a very, very new subject, and I agree with you. It's so fascinating, and it will be an essential part in the future of technology and technological systems. I am sure.
Thank you.
So many more thanks from Anita Wilson, from for Tanchi, and from Carl Lippert on the chat. A great presentation. Thank you for formalizing this thing. I love your contact, you, and I do love to contact you online. So I'm sure you will receive really many contacts. So last chance for questions or comments from the audience. So
I just want to say thank you again for inviting me to speak. I really enjoyed my time here this morning, and I'm glad to connect with my fellow engineers and colleagues here to discuss these topics and other things as well.
Thank you, Holly. Thank you so much.
So thank you.
For this terrific presentation. I work in systems and I learned so much from you. about something that I didn't consider. So anyway, thank you, and thank you also for sharing WISE. I like very much that abbreviation, WISE, wise women. Okay, thank you.
So wonderful. The presentation apparently is already available online, and Holly, we already had requests even before your presentation to have that available, and so it could be distributed. So with that, I would like to thank our speaker again. Thank you, Holly, again. And thank you, everyone, for being here today. I would like to thank the team again, and Goredna, and Ramalata, and Bozena for being with me organizing this series. And please keep tuned for the next presentations in the next few weeks. So thank you, everyone. Thank you, Holly. We will be in touch again, I hope. And I think the meeting can be closed now. And thank you, everyone, for attending it.
Thank you.
Bye-bye.
Bye.
Bye. Bye-bye.